All right, so today what we're going to do is we're going to simplify radicals and square roots, and we're going to talk about complex numbers. And so the reason we're going to do this is we have finished factoring, and there are several different ways we can solve quadratic equations. And the first one is solved by factoring, right? We learned how to factor, we set it equal to 0, and we solve. The next way we're going to solve, we need to know how to simplify a square root. So first of all, the square root, this part is the radical sign, and what's underneath the radical sign is called the radicand. And so not written here, there's no number here, but that's where our index goes. And the index determines how many of a number you need to have to take it out of the radical. If it's not written, we assume it's 2. So here, the index is 2. If it's not written, it's 2. But it can be a cube root, it can be a fourth root, it can be a fifth root. It can be whatever root you want. But if it's not written, we assume it's 2, which is the square root. And the square root uses perfect squares. And a perfect square, when we factored, is a number times itself. So what multiplies by itself, what multiplies by itself to make 4? 2. And 9? 3. Okay, so there's 2 ways to simplify a square root. And I'm not sure how you've been shown, but I'm going to show you 2 ways that in general work pretty well. So first of all, we're going to talk about prime factorization. And prime factorization means we're going to use prime numbers. And the numbers we're going to use most of the time are 2, 3, 5, and 7. They're the most used. But 11 is a prime number. 13 is a prime number. So this isn't all of the prime numbers, right? This is just most of the time the prime numbers we're going to use. So if I look at 108, I'm going to do this. I'm going to pick a prime number. And since this is even, I'm going to start with 2. And so that gives me 54. It's even, so I'm going to do 2 again. And that gives me 27. Can I divide 27 by 2? So I'm going to switch to 3. And so what can I divide 9 by? 3. And do you see how I end up down here on the bottom with a prime number? That means we're done. Okay? So now, outside, do you see the outside part? Those are the numbers that if I multiplied together, they would equal 108. And if you had a better math teacher, I would use all the math words and I would teach you the right way. But I'm going to tell you this because you will remember this always. If we think of the radical like a house, it's a house. To get out of the house, you have to have a date. So if I look, the 2s, they have dates, right? They get to go outside. The 3s have a date. They get to go outside. Who didn't have a date? That 3 has to stay home. And the numbers that you take outside, we're going to multiply together. So 2 times 3 is 6. Square roots of 3. And the reason I say a date is because what did I say the index was here? 2. So I have 2 and 2. If the index is 3, I would have to have 3 to get outside of the house. Okay? So this is called prime factorization, and this I'm usually going to use on the big numbers because you got to see all the numbers. You can do what's called dividing out perfect squares, and it's faster, and that works better on smaller numbers. So if I have 108, what multiplies together to be 108? 12 and 9. Because 9 is a perfect square, right? But inside the 12, is there another perfect square? What? 4 times 3 times 9. What's the square root of 4? What's the square root of 9? And what's left? So you get the same answer whichever way you choose to do it. Okay. So if I do this with variables, if I have 4 x's, how many dates do I have? I have this one and this one, so I have x times x, which gives me x squared. But I also want you to see, because we can't draw out 11 x's, right? We don't have time for that. But what's my index again? 2. So what is 4 divided by 2? 2. What would 8 divided by 2 be? So if I have x to the 11th, does 11 divide by 2? No. But could that be x to the 10th? That's my closest even. And then one more x by itself. And so what's 10 divided by 2? So 5 of x's get to go out, and that x had to stay home. X to the 25th, the closest would be x to the 24 with an x left. So 24 divided by 2 is going to give me 12, and that x stays home. So 25, I want the closest even number to 25. That's 24. 24 divided by 2 is 12, and that x has to stay underneath the square root sign. Say that again. Right, the closest even number to whatever is there. For instance, the 11, the closest even is 10. Okay? Okay, any questions so far? Yes, you're good? Yeah, are you good? Okay. All right, so look, y'all, the square root of 40. This is what I'm talking about. The smaller numbers, sometimes the perfect squares are the easiest, right? And the square root of 40 is 4 times 10, so that it gives me 2 square roots of 10. But if you like doing this way, you're going to get the same answer. So you get the same answer either way. Okay, you guys do 45 and... Okay, so I got 3 square roots of 5 for the square root of 45. And if you did it with the perfect square, it's 9 times 5. The square root of 9 is 3, and the 5 stays in. Okay, so what about 180? What did you do with 180? All right, so if I divide by 2, I get 90. Then what did you divide by? 3, and you get 30. And then? And 10. And 5 is one of our numbers, so we stop. So now where are my pairs? Right, I have a pair here, and then a pair here. So I have 2 times 3, which gives me 6 square roots of 5. Yes? Okay. Okay, so now let's look at the square root of 49, x to the 6th. First of all, what's the square root of 49? 7. So the 7 comes out. I have x to the 6th. So 6 divided by 2 is 3. So I get x to the 3rd. Is anything left under the square root? No. Okay, so 28. Let's do 28. Divide by 2. And 7 is one of our prime numbers. So I have a pair of 2's. The 2's come out. The 7 stays in. And I have x13, which is x12 and x. So I get x and then x to the 6th. Why wouldn't I what? Make it what? Okay, so look, the 13, right? If it's x to the, let me do this. I have 1, 2, 3, 4, 5, 6. I have 6 that can come out and 1 that stayed in. So if they're pairs, they go on the outside. If they're pairs, they go on their date. They get to go out. Otherwise, they're sitting at home. There's never a what? No, there's no third wheels. Nope, only dates. You only get a date. Yeah, Valentine's Day every day of your life. What? All right. 27. So 27, I'm getting a pair of 3's. So the 3 goes out, and this 3 stays home. Okay? So now, x to the 24th. What's 24 divided by 2? So we get 12 x's. I have y to the 5th. What's the closest even number? So how many y's? 2 y's and 1 stays in. Okay. Okay. Yeah, in your mind. You guys should be good at this. This is made up math. Made up math. You guys are good at this. Because you're good at it. Yeah, so you're good at it. If you type in the square root of -4 on your calculator, what does the calculator say? It says error. So I'm going to have this -1. I'm going to have -1 times 4. Y'all, what's the square root of 4? 2. And by definition, the square root of -1 is I. It's a definition, just by definition. They made up I don't know. It's I for imaginary. It's an imaginary number, and so we use I. I have no idea. And I don't know why they made it I don't know. But if I have the square root of 27, so I have a pair of 3's. Hey, shh. I'm talking about the imaginary numbers. Be quiet. So I'm going to get 3i and the square root of 3 because it's negative 1 times 27. I know it is. Always. The I gets to come out. So by definition, the I gets to come out. Okay? It's an imaginary. It gets its own rules. So it gets to come out extra. Okay, so we're all talking, so I assume you don't need me to finish, right? That's what we're all done? Okay. Did we already do 108? Yes. What did we get for an answer? 6 and the square root of 3. Okay. So if I listen, I know that the square root of 108 is 6 square roots of 3. So if I have a 6 on the outside, what do I do with the 6 and the 4? Multiply, so I'm going to get a 24. And what did we say? The square root of negative 1 by definition is I. And then I'm left with the square root of 3. Okay, so the square root of 16, what is the square root of 16? 4, and then I have the times negative 1, so I get 4i. This one, this is called a complex number, and it's complex because it combines a real number and an imaginary number. So the negative, the square root of negative 36. First of all, what is the square root of 36? 6. And the negative means I get I. So I get 2 plus 6i. So that's what makes it complex. There's a real part and an imaginary part. Okay? So that's the answer. You can't do anything else. So do you think I could add the 2 and the 6? I's, sweetheart. I. They're all I's. So you don't think it's literally by definition, that's what it is. Like it's just is. It's just an I.
So is it correct if I just put like a normal I?
I'm just moving on. So I'm going to start with the square root of 20. Shh. This is my last one. Let me do it. The square root of 20. Right. So I get 2 square roots of 5. So, but what do I need because it's a negative 20? What do I get in my answer? All right. So I have 8 plus or minus 2i square roots of 5 over 2. Now, what is 8 divided by 2? 4 plus or minus. And what happens with the 2's? They cancel, and I get I times the square root of 5. And that's your real part and your imaginary part. Right, because it's just like in parentheses. It's protected, right? You can't do that.